So in this lesson, I will show you how to find the angle of intersection between two planes. So from the equation of plane, from two equation of plane, we try to find the angle of intersection. So given that the plane P1, let's say I use the P as a plane, plane number 1, which is A1x plus B1y plus C1z is equals to K, and P2, the second plane, which is A2x plus B2y plus C2z is equals to K. So the angle between two planes can be determined by find the number of P1 and P2. So P1 and P2 actually is A1, B1, and C1. What is A1, B1, and C1? So A1, B1, and C1 is the coefficient of X, Y, and Z for the first plane. And then the N2 or A2, B2, C2, the second normal vector, is the coefficient of X, Y, and Z from the second plane. So you can see A1 is the coefficient of X. B1 is the coefficient of Y, and C1 is the coefficient of Z for the first plane. Whereas A2 is the coefficient of X, B2 is a coefficient of Y, and C2 is a coefficient of Z for the second plane, P2. So we are using A1, B1, C1 from the first plane, and A2, B2, and C2, A2, B2, and C2 from the second plane. So from there, we can use the formula cos theta. This one we have learned before. This is the dot product. Dot product, to find the angle between two vector, we can use the dot product. Same as this one. Cos theta is the dot product of n1 times n dot product of n1 and n2 over the magnitude of n1 and n2. So and then we can find the cos inverse. So we can find the angle. So let's look at example 7. If you look at this example 7, consider the plane with the equation 3x plus 2y minus z is equals to 1, and x minus y minus z is equals to 0. So this is the equation of plane. So here we have two equations. This is our P1, this is our P2. Find the angle of intersection between two planes. So from these two planes, we try to find the angle. So you can see, say, wait, this one. Okay, sorry. Oh, you can see from here. Okay, right. So if you look at this example 7, this is the two plane given, the equation of the two planes given. So now we want to find the angle of intersection. So from N1 and N2 is the coefficient of X, Y, and Z. So you can see from N1 is 3, 2, and -1. So here is 3, 2, and -1. Our N2 is 1, -1, and -1. So 1, -1, and -1, which is the variables of X, Y, and Z. So by using the dot product, cos theta is equals to dot product of N1 times N2, N1, N2. So this is the dot product. This is the magnitude. So from this magnitude, you can find the value. Finally, the angle is the cos inverse of this one. So you should find the angle. So let's look at the exercise. Exercise 7. Find the angle between the plane. This is the equation for the first plane and the equation of the second plane. So from this plane, so this is, let's say, is P1 and P2. So from P1 and P2, we can get the N1, the normal vector, which is the variables of X, Y, and Z. The variable of X for P1 is 1. The variables of Y for first plane is 2. The variables of Z for the first plane is -1. And then try to find the N2. Again, the variables of X for second plane is 1. Y is -1. Z is 3. So here is N1 and N2. In order to find the angle cos theta, is the dot product of n1, n2 divided by the magnitude of n1 and multiply with magnitude of n2. So we can try to find it separately. After that, we can substitute into the formula. So let's say I use another color. Let's say the back color. The dot product of n1 and n2. So where our n1 is 1, 2, and negative 1. Our n2 is 1, negative 1, and 3. So the dot product will be 1 times 1 plus 2 times negative 1 plus negative 1 times 3. So since negative 1 is negative, so we put a bracket, negative 1 times 3. So from here is 1 minus 2 minus 3. So here 1 minus 2 is negative 1 minus 3 is negative 4. Then we try to find the magnitude of n1 and n2. So the magnitude of n1 will be equals to square root. And we square each of the element in n1, which is 1, 2, and negative 1. So 1 squared plus 2 squared plus negative 1 squared. So here we should have 1 plus 4 plus 1, 4, 5, and 6. Square of 6. So magnitude of n2. Square of each of the element in n2, which is 1 squared plus negative 1 squared plus 3 squared. So here we should have 9 plus 1 plus 1, 9, 10, 11, square root of 11. So finally, cos theta is equals to the dot product of n1 and n2, which is negative 4, over the magnitude of n1 and n2, which is square root of 6, and square root of 11. So theta is equals to cos inverse negative 4 over square root of 6 times square root of 11. So by using your calculator, this one, let's say square root of 6 times square root of 11, negative 4, negative 4 divided by answer. So shift cos answer. I should get 119 point. After I round off, I should get 50 degree. So again, let's say I try to calculate again. Negative 4 divided by square root of 6 times square root of 11. So shift cos inverse. Yes, so the answer is 119.50 degree. So here is the angle between the plane. So we can use the dot product, which is cos theta is equals to the dot product of n1 and n2 over the magnitude of n1 and n2. How are we going to find the n1 and n2? Which is the variables of x, which is the coefficient of x, y, and z. So you can see 1, 2, and negative 1. Here is n1. N2 will be 1, negative 1, and 3. So 1, negative 1, and 3. So from here, we can find the angle between the plane.